So if you're watching from home, I forgot to hit record. Sorry. Just write this stuff down here on the right real quick and then hit play. All right, so some simple graphing coming up. As far as I'm concerned, the only number you ever need to have on a number line is 0. Unless you don't want to do like 40 tick marks, then you can just say this spot's 40. Most of your problems aren't that big. So this is graph x being greater than or equal to greater than -5. Well, I'm just going to go back 5 places. And there's my -5. That's the easy part. When I actually plot the dot, is it going to be open or closed? Open. That symbolism does not have an equal in it. There's no bar underneath. I know that some teachers will say solid line, solid dot. So you might want to add that to your notes. I don't know. Now, this one was given so that x was on the left. It is a greater than symbol. How are you going to shade? Right. And right makes sense. Is -4 greater than -5? Is 0 greater than -5? Yes. You shade the direction that makes sense. Anybody got any questions on A? Did I go back and fill it in? I did. There we go. Easy fix. I'll do the easy stuff on B here. I need a 0. I need a 3. How about this dot? That is a closed dot. You've got a bar underneath. You've got a solid line. Solid line, solid dot. Symbol, this reads x is less than or equal to 3. The symbol is less than. Give me a number less than 3. 2, 1. Don't those exist on the left? So which direction are you going to shade? Left. And I know some of you are like, oh my God, why is he teaching this? Because if I don't, half of you will miss it. At least half. I've had 1,100 students. I pretty much know where you're going to mess up before you ever mess up. It's going to be on little things like that. All right, this one's called the compound inequality. There are ways of breaking this thing up, but look at x. Is it lying between two things? Lies between two numbers. Guess how you're going to shade? You're going to shade between. That's how it works. So it's pretty simple. You just plot your numbers. I agree with that, Garrett. -3 is closed. How about the other one? Open. If you don't get that, just look at the inequality symbols. Now, when you read this thing right here, what is it saying about x's relationship to -3? No. It is saying that x is greater than -3. Read right to left sometimes. Sometimes you got to read right to left, kids. You just have to. So it wouldn't make sense to shade to the left, would it? It's saying shade right. I don't really shade, I just draw arrows. That's all I ever do. What's this thing saying about x's relationship to 4? Less than. So like 5 wouldn't work, would it? But anything else would. And I'm just an arrow person. When you do the IXL lesson, you'll see that you actually do some shading and plotting points. All right, anybody got any questions about the compound inequality? That one's technically called an AND situation. Next one's called an OR. And I won't say always, I'll say usually. ORs shade opposite directions. OPP for opposite. Honest to God, the reason I don't write the word opposite is because half the time I misspell it. I don't know why. I just never can seem to spell it properly. Aside from that, it's everything you've been doing. What kind of dot at 1? Open. What kind of dot at 2? Closed. Mallory, how are you going to shade at this open dot? How's that? What is X's relationship to that one? Well, read this to me. What does this first part say? 0 less than 1? Is -1 less than 1? Does everything to the left work? You're going to shade left. Austin, how about at the 2?
So you go right.
Go to the right. Who's your daddy, out of curiosity?
My stepdad is Carl Jr.
Okay, no. I was just curious if you're related to a Blue I knew. And there we go, kids. Shaded. Now, if you've got colored pencils, you can make this like you did in 6th grade. You remember you actually drew the arrows and they were pretty? I don't care about that, to be honest with you. In my mind, that's a huge waste. Huh? Used to do what with it?
Make lines or capital, like if it was like that, I draw on like.
That's what it takes. At least you're entertained by it, right? Here comes solving. Solving is really easy. Just treat the inequality symbol as an equal symbol. There is one thing we'll add in when we get to it. But the first example doesn't require that. Just treat that inequality symbol as an equal symbol. Just do what you would always do. So if you were looking at example A, what would you do? Subtract 9. You can talk, Devin. Subtract 9. What is 25 minus 9? 16. What else would you guys do after that? Divide by 4. Not equals. Less than. X is less than 4. That's all there really is to solving, kids. It's just plain old algebra. The symbolism does not change anything you have ever done. Everything in math is cumulative. We don't teach you something and then you have to throw it out for this situation. It's all cumulative. Every bit of it. It always works. That's the beauty of it. What you need, Dylan? You stretching? What's your question?
I don't know how you usually write up as you subtract. I don't care if I brought my number down.
No, I don't care. You know what I care about? That it's right. And that I can actually follow it. That matters too. Some of you guys, I don't know how you do algebra, but like you never put your X's down. You just put the numbers. No. Yeah, I know. So fix it. If you know what your problem is, fix your problem. If you know what your problem is, fix your problem. Or at least pay extra attention while you're doing it. Like, oh crap, I need to double check myself. Fix your problem. We're not going to worry about checking. I'll talk about checking at a later date. I don't care about checking right now. I guess we need to graph it. Why don't you guys graph that real quick, because I haven't actually seen you graph anything yet. Graph X is less than 4. Other than the person who has yet to graph it, I didn't see anybody get it wrong, so I'm going to go over this for anybody who's at home watching. So there's my 0. I got to go up 4 places, open dot, and I am shading to the left because I am less than 4. Anything less than 4 is going to work, like a 3, a 2, a 0, a 1. A couple of you guys have already done B, and I didn't check to see if you did it or not, right or not, but it needs to be talked about. Normally, if I did B, I would actually shift my x's right, but for teaching instruction, we're just going to put our x's on one side, numbers on the other, and we'll put our x's on the left. That's not a rule. You don't always have to do that. But we're going to put x's on one side. We're going to put numbers on the other. It's one of the first things you ever learn how to do in algebra. And I am going to shift to the left because something needs to be taught here. So this x comes to the left. What happens to its sign? It becomes negative, right? There was already a negative x on the left. And now we're introducing another negative x. Yeah, we'll worry about that in a second. Not disagreeing with you. That 3 is going to shift right. There was already a negative 9 there. What happens to sign on the 3? Negative. Comes negative. So Garrett told me there was actually a negative 2x there. And I think I heard some young lady say there was a negative 12 here. What you got? First off, it's not equals. We divided a negative out. Anybody remember anything from algebra 1? Flip the inequality. It's no longer greater than. It's less than. So if you didn't remember that, you should probably write this down. When dividing or multiplying, actually, because some teachers teach doing this stuff through multiplication instead of dividing by a negative, they multiply. When dividing or multiplying by a negative, you flip the inequality. Now, what I want you guys to do is work on C. I forgot to graph that, didn't I? Don't worry about the graph. I want you guys to work on C until you're dismissed for lunch. And we'll go over that as soon as you get back in from lunch. So work on C, solve it, graph it. Probably already done, half of you are anyways. So you jump it over and it's -1. And what is a -14 minus 1? -15. A couple of kids have been saying 13. You see some 16. You see 13 show up a lot. Here comes that divide by a negative. What do you do to the inequality symbol when you divide by a negative? Flip it. So you'll get x is greater than or equal to a positive 5. Because a negative divided by a negative is positive and so forth. As far as plotting goes, pretty simple. It is a closed dot. And it is a red x is greater than or equal to 5. So how are you going to shade? Left. So you should be giving me some indication of shading that way. Anybody got any questions on that? Those of you at home, sorry about the 20 minutes of nothingness. I'll make comments on that when I post the video. Now, this is an equation that basically has two equal symbols. We'll talk about, the general idea here in a second, but that says negative x minus 5. What do you want to get rid of next to x? How do you get rid of a negative 5? Can you just add it here? Add to both. You are adding it to all three pieces. What you do to the middle, you have to do to the ends as well. So the big deal here is balance purposes, and I'll just write it this way. What is done to the middle must be done to the ends. Or just one of them. It wouldn't make sense. It wouldn't be balanced if you didn't give 5 to everything. So we go through and we add our 5. What's negative 8 plus 5? Negative 3. 5's cancel. We've got a negative x on the interior. And 6 and 5 makes what? 11. Now we're going to divide out our negative symbol. We'll divide everything by that negative understood 1 in front of x. So the numbers themselves change sign. What happens to the inequalities? They all flip. Nope. Somebody get the door, please. Where you been? Now, if IXL has you solving compound inequalities and you put it in like this, I bet it would reject it. There was a compound inequality here, and this is kind of the standard idea. Small numbers belong on the left and big numbers belong on the right, kids. That's how it needs to look. That one's not written that way, is it? No, it's got a big number on the left and a small number on the right. Kind of all you do is you just kind of view it upside down. Flip the whole thing. Take the whole thing, rotate it 180 degrees. That's all you do. Minus the numbers, but they just swap spots. Flip the inequality symbols. Surely you remember somebody talking about that. That's how it's supposed to look. Now it says x is trapped between negative 11 and 3, not 3 and negative 11. Now x lies between. We only need two things on here. We need a 3. We need a negative 11. Both of them on this one, are they open or closed? Closed. Now you got to ask yourself is how you're going to shade. In between. Just look at the inequality itself. It's got x in the middle, shade in the middle. It's really that simple. You just shade the space in between. Nothing more. If you draw your arrows right, you'll see that x is in the middle. You shade them like that. Almost done. 3 more examples. Anybody got any questions you want to ask me? How many equations are present on this example? 2. So guess what you do? You solve 2 different equations, kids. It's this one or that one. So Why don't some of y'all do this one and some of y'all do that one? Just pick one and go with it. Do both if you want. They're easy. Shouldn't take you long. Actually, the only reason I had to do that one was I wanted to see how many people would miss 0/3. Thankfully, nobody did. Of course, some people didn't do the problem. Nobody missed what 0 divided by 3 was. So there's that. But what I saw looked right. Looks like you added 1 and you had 3x less than 0. You divided your 3 out, so x is less than 0. You didn't flip your sign. Why didn't you flip your sign? Divide by a negative. Right? Some kids get confused on that rule. And this one looked good too. You subtracted your 5. You divided by your 2, and you got that. It does say graph, and we actually just says solve, doesn't it? We're going to go ahead and graph it. This is an OR. How do ORs usually shade? Opposite away from each other, okay? And the word is usually. So just remember ORs usually shade away from each other.
I make 2 separate graphs, but they're still going the opposite way.
That's fine, but if you ever take a quiz or test, it'll be one number line. Because the idea is we want to put emphasis on the space in the middle. So they're usually together on the same one. What kind of dot at 0? Open. What kind of dot at 3? Closed. I don't keep my paper in just the right place. The person watching at home can't see it. And they're going to shade away from each other. I mean, that's just the deal. And you can check it. That says less than 0. That's left. That says greater than or equal to 3. That's right. Less than is left. Greater than is right. Any questions whatsoever? I'm sure you're just ready to get started on doing it your own. Now here's the opposite of what we've been doing so far. Write the equation given the graph. Now think about what you know. Hold on, let's just talk at the basics. Look at the graph. Is this an OR? It's not an OR. It's actually called an AND. Is the bottom one an OR? Yes. So when you write the not an OR, and we'll go ahead and do A, and Garrett, what are you talking about?
Well, the open circle makes it either greater than or less than. Or equal to.
So here you're thinking it's going to be a greater than or less than, no equal, right? What are you thinking here? The symbol itself. It's got an equal in it, right? X is anywhere in between. X is that space between. This is a between situation. So just focus on your numbers. You've got a -2. You've got a 4, I think. And where does x lie? In the middle. Now think about your symbolism. What is everything's relationship to the -2? Greater than or equal to. So x is greater than or equal to -2. And again, don't be the kid who reads this and says that's less than equal symbol. Not in this context. You understand that? In this context, it is a greater than or equal to symbol because we're talking about x. What is x's relationship to that 4? Less than. Remember, x is anywhere between here, kids. That's just its boundary. What you got?
Wouldn't -2 and x have a different inequality? Because that would mean it's going this way.
No, it doesn't, because you're still looking at it and thinking it's a less than equal to symbol. Read like a Chinaman. How do Chinaman read? Right to left. X is greater or equal to 2. Sometimes you got to read right to left. All right, we already know we got the word or, right? You know, and just focus on your numbers first. You got a -1 and a 2. Two separate equations. What's x's relationship to -1? Less than, open dot, not going to have a bar. What's its relationship to 2? Greater than or equal to. That covers it. All right. Now, let's see what you are now able to do on IXL. I'm going to teach some more tomorrow. I'm not just going to let you do IXL tomorrow. But there will be a day this week where I'll let you catch up on some work. It's just not tomorrow. I'd like to talk about absolute value tomorrow. So what you should be able to do so far is C1, C2, and I would dare say, for the most part, although we've got some more to work for it, C4. But for sure you can do C1 and C2. And I may add on to this and let you do C4 and 5 tomorrow. Sure you can do C1, C2, and I'm sure a lot of you already have. Need any help? Ask me. Still got 10 minutes in here.